My name is Dr. Richard Williams and I'm going to be presenting this short video to provide context for the georeferencing exercise that you'll be undertaking using data from the Rees River. The intended learning outcome of this short video lecture is to describe the geomorphology of the Rees River and the data collected as part of the ReesScan project. The ReesScan project was undertaken between 2009 and 2010. It was a project funded by the Natural Environmental Research Council in the United Kingdom, but undertaken in the South Island of New Zealand to understand morphological change of a large braided river, the Rees River. The location of the Rees River is shown on the map on the left-hand side of the screen. On the right-hand side of the screen, you can see an aerial image that shows the Dart and Rees rivers, the Dart to the west and the Rees to the east, east being to the right of the image, and the location of those two rivers and the confluence between the rivers as they flow into Lake Wakatipu. You can see that lake in green shading in the aerial image at the very southern side of the image. Here's a picture of the Rees River. As you can see, the Rees River is formed of a number of interlocking or braided channels. In this image, flow is from the bottom of your screen to the top of the screen. In the georeferencing exercise, you're going to be focusing upon understanding the change in the location of river channels within the area that's highlighted in red. This area is just upstream of a road bridge, and that road bridge is the only place where traffic can cross this river. The Rees River catchment can be thought of as a huge sediment cascade. The origin of a large proportion of the sediment that's supplied to the downstream areas comes from very active landslides, such as the one shown in the image in the top left-hand corner of this slide, which is called Muddy Creek. You can see the bare slopes across an elevation range from the top to the bottom of the image of almost 1,000 metres. During high rainfall events, a huge amount of sediment is readily available to be eroded, transported along this tributary onto an enormous alluvial fan that's connected to the Rees River and shown in the next image to the right. Sediment is transported through the Rees River, through several gorges, and then out from the mountain front area onto a wide alluvial braided plain. This plain is shown in the image to the right, which has been captured at low flow, and then the image further down in the bottom right hand corner shows the Rees River flowing out onto its delta, where it joins the Dart River, and finally discharges into Lake Wakatipu. You can see that sediment discharging as a fine sediment plume in the image on the right hand side. And that delta is prograding into Lake Wakatipu by about 1.5 metres per year. An indicator of very, very high geomorphological processes. The ReesScan project took place between September 2009 and May 2010. I was part of an international team of scientists that monitored the morphological evolution of the Rees River during this period. We undertook 10 surveys to capture the topography of a 2.5 kilometre long reach of the Rees River. At each survey, we acquired topographic data from terrestrial laser scanning, and we also acquired aerial imagery of the braided reach. This hydrograph shows how discharge along the river varied during the survey period, and we tried as much as possible to capture the topography of the braided reach before and after every high flow event. We are interested in understanding how different sized flow events alter the morphology of the river, and you can see that we captured a really good range of low, moderate and large flood events during this monitoring period. I want to give you some appreciation of what the Rees River is like during low and high flow periods. This video shows the Rees River at low flow. We can see that bars are aerially exposed, and as the video zooms in, we can see a number of chute channels that are cutting between smaller bars. High flow events, all of those bars are inundated by water. In this video you can just see in the distance a log being transported downstream, and this is where most of the geomorphological work, the sediment transport, actually occurs in these multi-channel rivers. You can hear the noise of birds on there, but you can also hear the power of the river and stones actually moving along the bed of the river as the morphology of the river varies. This video shows a helicopter taking off, and at the bottom of the helicopter you can see an SLR camera that has been mounted to acquire images from the sky looking down at the Great Plain to record the position of the Rees River's channels. In the exercise today, you're going to be mapping channel change. You're going to be given one aerial photo that was acquired from one survey that's been georeferenced, and during the exercise you then need to georeference a further image to investigate how the channel has changed as a result of a high flow event. Image B on this slide shows the positions of the Rees River channels during the 11 surveys that were captured during the Rees Scan project. You can see that this river is enormously dynamic. The challenge in the georeferencing exercise is to just understand how the channel position varied due to just one flood event. So I hope this video has given you an overview to some of the geomorphology of the Rees River, and also how we acquired the aerial image that you'll be georeferencing as part of the exercise for this MOOC.